let's take another look at the derivative. Specifically, we want to look at what's called the numerical derivative and use that numerical derivative to find the equation of the tangent line. Now, we remember that the derivative is the slope of the tangent line. Now, I want to look at this specific tangent line at the point where x is equal to a. So we're talking about this point, where the x-coordinate is a, and the y-coordinate then would be f of a. And we're going to develop this slope in a very similar way that we did with the derivative function. By that, I mean we're going to start by looking at a secant line. So I'm going to pick this other point, some other spot where we have an x coordinate. So this point would be x, f of x. And taking a look at the secant line between these 2 points. Now, the slope of that secant line is found in the normal way, f of x minus f of a over x minus a. But as we did before, we want to find the slope of the tangent line by moving that point along the curve until that second point lands right on top of our specific point, a, f of a. And we're going to do that by letting this general x-coordinate turn into that x-coordinate of a. So our derivative specifically at the point a is going to be that limit as x turns into a of f of x minus f of a over x minus a. And this gives us that slope at a very specific point instead of giving us a derivative function that would give the slopes of tangent lines at every point on the curve. All right, so let's try and find the equation of the line tangent to f of x equal to x squared when x is equal to 5. Now remember, the 2 things you need to come up with the equation of a line are a point on that line and the slope of that line. Now we can quickly find the point that's on that line because we're talking about the line tangent when x is equal to 5. That means the x-coordinate is going to be 5. And in order to find the y-coordinate, we just plug that into the function. We'll have 5 squared, which is 25. So there's our point, 5, 25. In order to find the slope of that tangent line, we're going to need the derivative of f at 5. So we use that limit definition, and we're going to let the x-coordinate turn into 5 for f of x minus f of 5 all over x minus 5. So we do a little substituting first. We still haven't taken the limit, so we keep our notation around. And we haven't done anything with our denominator, so we're going to keep our denominator around. F of x is x squared. F of 5, we just said, is 25. Now we can factor that numerator. I have to keep the limit around, have to keep the denominator around because we haven't done anything with them yet. But factoring the numerator into x plus 5, x minus 5, we see that we can do a little bit of canceling here with our x minus 5s. So we're really looking at the limit as x approaches 5 of x plus 5. Now we can take that limit by turning x into 5, and we get 5 plus 5, which is 10. That is our slope of the tangent line, and we already have our point that's on the line. So we put those 2 together to create our equation of line using point slope form. Y minus the y-coordinate is equal to slope times x minus the x-coordinate. And there's our equation of the tangent line. Let's try another one. One that's a little bit more complicated, but the idea is still the same. First of all, we need a point. We have an x-coordinate of that point is 3. To find the y-coordinate, we're going to take 3 and plug it into g of x. So we'll have 3 times 3 squared plus 5 times 3 plus 1. That looks like 27 plus 15 plus 1. So 30, 42 plus 1 is 43. That's our y-coordinate. In order to find the slope of the tangent line, we're going to need the derivative when x is equal to 3. So we use the numerical derivative, the limit as x approaches 3, of g of x minus g of 3 all over x minus 3. So we substitute first, keeping our limit notation around and keeping our denominator the same. G of x was 3x squared minus 5x plus 1. And we just said that g of 3 is 43. Clean that up just a little bit. 3x squared minus 5x minus 42 all over x minus 3. Now, when we're factoring this, we are fairly certain that we want that x minus 3 to cancel. So that would mean that the other factor would have to have 3x there and 14 here. In order to get the negative sign, this would have to be a 3x plus 14. And of course, you can FOIL that out to check, and we would be right that that is how 3x squared minus 5x minus 42 is factored. Then we go through and cancel our denominators. We're left with the limit as x approaches 3 of 3x plus 14. So we can evaluate that limit by plugging 3 in, and we'll have 9 plus 14 is 23. There's our slope. Here's our point. So now we can write the equation of the line y minus the y coordinate is equal to slope times x minus the x coordinate. And there's our tangent line. Let's try one more, one that's not quadratic. The idea is still the same. We need to have a point. We know the x coordinate is going to be negative 2, but to find the y coordinate, we're going to take negative 2 and cube it, which would be negative 8. So that's our y coordinate. Next, we have to find the slope of the tangent line. Notation-wise, since I'm not dealing with functional notation, I'm going to use Leibniz notation, which looks a little bit more complicated. But Leibniz notation, remember, is that dy dx. To show that we're going to evaluate it at negative 2, we use this long vertical line to say dy dx evaluated at x equals negative 2. But the idea is still the same. We're going to find the numerical derivative by taking the limit as x approaches negative 2 of f of x minus f of negative 2. Well, in this case, we don't have f of x, but we got x cubed is our function minus f of negative 2, that functional value, the y coordinate here, so minus a negative 8 over x minus that negative 2. Since we're dealing with the sum of two cubes, when we factor, gotta keep that limit notation around, gotta keep my denominator around, but one of the factors is going to be the cubed root of each term, so cubed root of x cubed plus cubed root of 8, which is 2. Then we get the long factor where we square together squared, so square that x, put the 2 and the x together, and that's going to need the opposite sign, and square the 2 for the plus 4. Now we'll have a little bit of canceling that happens. The x plus 2's cancel, and we simplify that into the limit as x approaches negative 2 of x squared minus 2x plus 4. When we substitute, negative 2 squared is 4 minus 2 times negative 2 plus 4. Well, that looks like 4 plus 4 plus 4, which is 12. Our last step now to write the equation of line, we have our slope and we have our point. So the equation of our line is y minus the y coordinate, negative 8, is equal to slope times x minus the x coordinate of negative 2. And there's our tangent line.